In this video, we're going to do a trace of executing merge sort on a sample input. So I already have up top an array. So merge sort, right, we're going to be always simulating it on an array. So I have an array. This goes from 0 to 7, or n. I'm not going to be too picky about tracing my indices right now because I want to go through the visual process with you guys. All right. So we already know the basic algorithm from the previous video. So what do we need to do? First thing is going to be to split. So we need to find the midpoint and say we're going to split there. So midpoint is this over here. Okay, we're going to split there between the 4 and the 5. All right. Then we're going to have two kind of resultant chunks, and those resultant chunks, right, are things we want to sort. So what I'm going to do is I'm going to basically draw these in as, basically new little arrays. Now, in practice, when we actually have the algorithm code, what happens is that it'll have different, each call of the function has different indices in it, and those indices are used to trace where you're working. Like you're working from index 0 to index 3, or index 4 to index 7, right? It'll track which indices are active. Here, right, we're just going to be drawing it visually because it's kind of cleaner to understand it that way. But in practice, this is all happening inside of one big array, and you're just tracking the different indices. All right, so we have this, right? We've done kind of one step of break it down. What do we need to do next? Well, we need to sort our left and right sides. But the thing is, I'm going to do the same process again, right? My only way to do sorting, right, is going to be to do it, by running merge sort recursively. So I'm going to need to repeat the same process. You can imagine, right, you're calling merge sort again. First thing you have, and then you merge sort call is going to be another division operation. So that's what I'll have to start with. So over here, I'll end up with these two and these two, right? So this is my kind of my second recursion call, or it's my first recursive call, and it's happening twice, right? It's happening for either side, and that's too big. Next step is going to be to repeat the same thing for the right-hand side. So again, I'm going to break it into two chunks. So I'll have a chunk for 5 and 6, and then a chunk for 7 and 1. Okay. Now I have 4 arrays, and I need to sort all 4 of them, right? Before I can do that merge step, right? The merge step is the last part of the call of the algorithm, right? But I can't really get there until I'm done sorting everything, and these are kind of still unsorted. So I need to break these down again. So I'll break these down, and probably I'll stop drawing my boxes because it'll be a lot of boxes now. Okay, 5, 6, 7, 1. Okay, so this is where we're kind of getting to the midpoint here of this algorithm running, because it's broken down everything from this huge monolithic array of 8 elements to just 8 single element arrays, right? And these are nice because one element by itself, that's got to be sorted. Okay, so we're basically done. Right? We've sorted all of our arrays. Right, is what we've done. We've broken it down to the point where it's sorted by default, if you would. But now we can start unraveling it, right? So we basically do that split operation. These are sorted. Now we want to do the merge operation, so we want to combine them. So there's this algorithm, right, that we're going to talk through that's going to take our different sets of elements and combine them together. Here I'll just go ahead and draw the answers. So here I'm starting with 8 and 2, so that means I go to 2 and 8. Afterwards I have 3 and 4, that's actually going to stay the same. 5 and 6, that'll stay the same. 7, 1, there will be a little change there. Okay, so I have kind of one level of merging, right? And these basically are supposed to be matching. Right, I broke something down, and now I'm building it back up. Okay, now I want to continue building it back up. Now I got to worry about this one. So I'm going to combine it into little arrays of size 4. So here in this case, I get 3, 4, 2, 3, 4, 8. Okay, over here on this side, I get 1, 5, 6, 7. And again, this is matching over here. Last step here, I have 2 arrays with length 4 now. What do I need to do? I need to combine them together to get something of length 8. On that case, I have one larger array here. Stitch them together. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I brought everything back together. And so now all of a sudden these match, right? So these match in terms of size. So I had to basically make these recursive calls that went 3 deep, right? Then they got down to that very, very small array of size 1, which is trivially sorted. And then I unraveled it, right? And I went back and combine until I get back to the whole size array. So yeah, that's how merge sort works, right? So again, the idea is take it, break it into pieces, sort the pieces, combine the pieces. And that's really all I have to do. All right, so hopefully this makes sense. Again, all right, this is kind of a visual trace. We'll take a look at the code in a few minutes. The main difference is going to be that instead of having these little chunks that I've drawn here, we're going to be passing around indices to indicate where in the array we're actually working.